show you yet. So the presentation that Lance just went over talked about smart TV. Who would have ever thought, even 5 years ago, that you could get the kind of experience that they demonstrated in the video and you can see around the room here on a TV? And this is, it shouldn't be surprising if you understand the Intel culture. This quote behind me is from Bob Noyce, who was one of the 3 founders of Intel. And this quote is actually hanging on the wall of the lobby in our Santa Clara headquarters office. It says, "Don't be encumbered by history, go out and create something wonderful." And we strive to do this in every area of our business, including PCs. So to get started, I just wanted to walk you through some stuff that you might already know. Hopefully I'll give you some new tidbits of information as well. So let's look first at what's happening just to that overall environment. We're talking about billions across the board here. The world is moving to the internet, and you see that we have about over 2 billion people in the world on the internet today. So, just under a third of the world's population is online. 247 billion emails sent every day, and most of those are junk email, but still it's a big number. We have 2 billion videos viewed every day, and then 2.5 billion images uploaded to Facebook per month. So, what's happening? How is this happening? It's happening across a whole range of devices. It's happening on PCs, it's happening a lot on smartphones, it's happening on tablets. There are a number of different devices that are playing here and offering a great experience. So is the PC dead? How many here think the PC is dead? Dying? Okay. Good. I'm just going to pick on you then. So, in fact, back to 1994, and what's happened with PC growth. And there have been a couple of things that have helped ooch along growth along the way. Innovation drives growth. Now think back to 1995 when Intel introduced the Pentium processor with MMX technology. Multimedia extensions, coupled with color displays for the first time, optical drives, turned these old utilitarian business boring machines into consumer devices. That drove growth. And then again in 2003, when we introduced Centrino technology into the marketplace and made wireless connectivity part of every single laptop PC. That untethered mobility really drove sales. I mean, look at the growth here, and this is overall client. If you look at just the mobile slice of this, it took something like offering a whole new way to use your PC to drive growth in the double digits for the first time ever in the mobile space, to where now mobile dominates the market. Now, just to put this in perspective, if I'm showing here the cumulative sales of iPads and Android systems, new technologies emerging, great devices, but keep in mind that when you hear about the fantastic growth, they're starting from a small base. And in fact, the yearly sales that we're expecting for PCs, even going forward, dwarfs this number, cumulative versus a yearly view. So the PC still has a very strong role to play here. So where's the growth going to come from? Well, it turns out there's a lot of people out in the world who don't have PCs at all. You guys can read the chart, I'm not going to read it for you. Big opportunity there. And where does this opportunity exist? And I'm going to explain this chart to you because it may not be intuitive. At the bottom here, we're showing weeks of income required to purchase a notebook PC, and then the density, the PC penetration. So you can see, for example, in a mature market like North America, PCs are very affordable. About a week's income to buy a notebook PC, and as a result, very high penetration. Same thing with Western Europe, more affordable, higher penetration. But look at places like India and Eastern Europe, lots of opportunity there. In fact, if you look forward, that was 2010 actuals, look forward to 2015, this is where growth is coming from. So you can see, let's use Eastern Europe as the example. As the affordability goes up, and it takes just a week or two worth of salary to buy a PC, the penetration is expected to go up to just south of 80%. So lots of opportunity here. This is an eye chart. I'm not going to spend a lot of time on it. I just want to explain that this green stuff is what people prefer to do on a PC. The red is prefer a mobile device, like a smartphone, and the blue is what they prefer a tablet for. The different usages are listed here. We have mature markets versus emerging markets. Now, the best way that I can sum this up quickly for you guys, because I know that you want to get to food, is that if you think about the PC is more of a lean forward kind of a experience, right? So those experiences when you're doing email, sometimes when you're doing online shopping, those kinds of things might be easier to do on a PC. They are the preferred device for those types of usages. Bigger screen, leaning forward. The lean back usages are going to fall more into the desire to use a mobile device. So anyway, there still is a lot of relevance for the PC across a whole range of different usage models. So the one thing that has happened with the advent of all these new devices in the marketplace is that, now you have touch, you have instant on capability. People don't expect that capability just on their phones. They want it on their PC. So it's raising the bar for the PC makers and the overall industry to deliver that kind of responsiveness and capability that they're getting on tablets today and on smartphones today in a PC form factor. So you don't sacrifice anything. You get the best of a PC and the best of a tablet all in one. Now at Intel, in the early days, we used to start with developing products. You start with the processor and the hardware. You have a really great processor, and what you want to do is you want to enable applications to take advantage of the new hardware you've put into the silicon. And then that delivers the great end user experience. Across the board at Intel, and I think you'll hear from every one of the speakers tonight, we're starting now with the user experience in mind. And even though this triangle is inverted now, that doesn't mean that the hardware is not critically important to the overall experience. You need to have that performance in order to deliver that great experience. But if you start with the user experience in mind first, you can build a solution that's going to make people want to buy the technology. So that's where Intel is right now. We think it's time to transform the PC again. We have growth opportunities in emerging markets. There's a strong desire still for PCs, but we have to innovate to continue to drive growth. And that's what this new category of Ultrabook is all about. So Ultrabook, what is an Ultrabook? The first thing you think when you see an Ultrabook, the first thing you notice is that it's very, very thin. But it's way beyond just thin. The systems that have been thin have been in the market before. But again, this is about going through a transition over time that merges the best of tablets with the best of the PC. That means performance, responsiveness, security, and all-day compute become critically important. So let's go ahead and start with performance. Now, a couple of years ago, Intel had brought its ultra-low voltage processors, which had been, in business for about a decade or more, to the consumer market, offering new price points, and we thought that it would change the world. Well, we thought it would take off in the market. Many of you have written about how it didn't, and one of the complaints that we heard from you is that the performance was much lower than the standard volt processors that went into traditional notebooks. We also didn't have people really designing to the lower powers that were offered. And so you didn't get that thin design across the board. What I wanted to show here is, I'll look ahead toward 2012. Since we first launched STULV, we've closed the performance gap between our traditional 35-watt processors and our 17-watt ultra-low voltage roadmap. Here in the middle, we're showing what a traditional laptop will look like in our 2012 platform. And you can see that Ultrabooks are going to be slightly lower performance, but we've really gone a long way to close that gap. I mean, this is showing it's half the power, less than half the power, and what does that look like to you? What percent of the overall performance? It's close. And think about it, the people who are going to be out buying these Ultrabooks, a lot of them are going to be replacing existing systems in mature markets. That's what's driving the growth there, right? So they're replacing technology that's maybe 3 years old. And so what they're going to see when they move to this Ultrabook is a huge increase in performance over their previous product. But these systems also have all of the goodness that's built into our core product family today. So think about it, the second gen Intel Core processor family has this great graphics and media processing capability. These Ultrabooks are going to come with all of the goodness that's built into the second gen Core family, including Intel QuickSync video technology, wireless display, and services like Intel Insider. And on the graphics side, the same Intel HD Graphics 3000 offering great mainstream gaming capability across a whole number of mainstream titles. But performance is just one aspect of the experience that we're trying to deliver. Another aspect is in the responsiveness. And I'm going to go ahead before I talk to this slide and get a demo started. I'm going to ask someone in the front to keep me honest here. So here I have the UX31 from ASUS. I know a lot of you guys have already taken pictures of this. Very thin system. This has, I have a Gmail browser open. You see is my inbox empty? Pretty much. Pretty much totally? Absolutely. Okay, good. So what I'm going to do now is I'm going to put this system to sleep, and we'll come back to it in a little bit. So when I put it into sleep, it's actually going to go into a hibernate state. I think I hit it right. We'll find out. Okay, now back to this slide. All right. So there are a couple of responsiveness technologies that we're introducing into these Ultrabook systems. The first one you may have heard about before. We made an announcement about it, primarily tied to the Z68 chipset at Computex this year. It's called Intel Smart Response Technology. And what this allows is for application responsiveness, so active responsiveness when you're running applications. Because this allows for use of a mechanical hard drive in conjunction with some local NAND storage, you can get about 80% of the responsiveness of an SSD at a much lower cost. So Intel Smart Response Technology is going to be available on some of these systems that you'll see coming to market over the next several months. The other technology is the Intel Rapid Start technology. And what this does is it allows that closer to a smartphone type of experience on a PC. So I'm going to take this system that I wasn't showing you before. So this is a system that's going to be announced by Acer tomorrow, the Aspire S series. And I don't want you to get too close a look at it because go to their event and see the launch. But I am going to start up a video just so you can see this is working. All right, so it's playing a video. I'll let you look at this for a little bit. Now I'm going to put it into a sleep state, which is actually hibernate. All right, so this one you can actually see it go into a sleep state. It went to orange, that went to sleep. What the rapid start technology allows the system to do is the end user puts it into sleep, where it pushes a button, it goes into a sleep state. But it doesn't stay in sleep very long, it goes into hibernate. Now, hibernate is available on any Windows system today, so why doesn't anyone use it? Because on my system, with my IT load from Intel, it takes me about 55 seconds to come out of hibernate to get to my Control-Alt-Delete screen, my login screen. It takes forever. So what do? I put it into a sleep state. The problem is that when I'm in sleep state, I'm drawing power. It's having to keep things active so that I can come back to that same experience. With the smart response technology, the end user doesn't even have to know they're going to hibernate. What they're going to know is that the battery life while they're in standby is going to be longer. So it's going to be, weeks instead of days at best of battery life. So now this thing is, all the lights are out. No lights, no one's home. All right, so when I hit this button, you guys can start counting. It should come back. If the demo gods are with me tonight, it should come back in under 7 seconds. So, starting now. Did it come back? All right. Thank you. All right. So again, you're gonna get responsiveness like you resumed from sleep, closer to instant on than you're getting today, but all the power benefits of that hibernate mode. Now, let's talk about the Smart Connect technology. And I hope that I put this to sleep properly. Thomas, did you send me an email? Okay. All right, what Smart Connect technology does is, this system is also in hibernate right now. So it's in that same low power state. The difference is that with Smart Connect technology, the system will actually wake itself up based on your requirements. Maybe you just want it to wake up once during the night and download all of your content. So it can download your email, your RSS feeds, any kind of content that you normally have to pull from the internet. You can do an automated pull, a programmable pull from the internet. Then it wakes up for a while, it does the pull, and it puts itself back into that hibernate state, which is pretty cool. So now, if I shut this down right, what's going to happen when I come back is that it will also wake. And there's an email in my inbox. There's an email in my inbox, so let's open it. Make sure it's a real email here. Okay, see if you can open that. I have to move on. Let me know when you have it. This is the audience participation part of the program. The email's there?
It is.
Okay, good. I can't work the system tonight. Sorry about that, guys. So now you have these really cool systems that you're going to want to take with you everywhere. So what's the next thing you worry about? It's so pretty. What if someone steals it? Well, Intel has a whole breadth of security solutions that we're working on across the company, including technologies to help protect your asset, to protect your data, to protect you from malware, and to protect your online transactions. Intel protection technology, identity protection technology, the first one is shown here, is a hardware-hardened mechanism that allows your online transactions to be more secure. So in Europe, you have to use little tokens sometimes to get into your bank accounts, right? This hardware replaces that token. So it automatically does a hardware handshake with the site. The site recognizes the PC, you're locked in. We showed at CeBIT this year, we had Gabe, the famous gamer guy, actually give out his account name and his username and his password, and no one could break in because they weren't on the right hardware. So that's going to be included in every single Ultrabook device. The other thing that's going to be included in every one is the Intel anti-theft technology that allows it, that should deter theft of the system, because once the user reports the system stolen, it's automatically shut down. So a poison pill is sent down the line. The thing is as useful to the thief now as a paperweight. You can't access the data, you can't get anything off of it. So that will deter theft. Of course, if you find the system, you're able to restore it. But in the meantime, the asset is useless to them. They can't take out the hard drive and sell the rest of the system. The system is dead until you, the owner, restores it. And the last area that we're working on for Ultrabook is that idea of getting to all-day battery life. So, SoC, system on chip. Remember Lance was talking about system on chip. Right now, if you look at how Intel is designing our products, we have a current notebook design target that's around 35 watts. Now we have ultra-low voltage that we scale down, but our design point is up here, and we scale down. And then we have this other SoC design targets that are in that 10 watt or less kind of range today. So what we're doing for notebooks is we're actually moving the design point down to less than half. So we're not scaling down now. That about 15 watts becomes the new design point. That means we're going to have great performance in a lower power. That's going to become the new normal for mobile computing. And that capability, along with some other goodies that we're building in, is going to help get to that all-day battery life target. But it's not easy. Like Lance said, simple is hard, or what Jobs is saying that simple is hard. Ultra is hard too. And it can be expensive to do all of this. And so Intel's doing a number of things to help enable the industry. First of all, we traditionally work with our OEM customers, the system manufacturers. And we also do some enabling of the ODM, the design community that is in China and Taiwan for a great part. But we're expanding that. We're doing deeper collaboration with OEMs and the ODM community. We're also working with suppliers of thin ingredients to make sure that we are giving them the right targets. We're sharing our manufacturing BKMs, our best known methods, so that they can get better yields. We're doing whatever we can to help them along. And then giving some low touch tools as well, some design guides and some other tools available to the industry. Now, in part, as a result of this work that we've done with some really good partners, we have a number of systems that are going to be coming to market in the second half of this year. So starting this week at IFA, you're going to hear a lot of announcements from a number of different players. So I just want to acknowledge the systems that I have with me here today. I already talked about the Acer Aspire S. We have the Lenovo U300S. We have the Asus UX31 and the UX21 over here. And then we have the Toshiba system as well. So each one of these, this beautiful system, each one of them is going to be available in market starting this year. So we're very, very excited about all of these offerings. Now the other thing you may have heard about, we announced it, I think it was 2 weeks ago in Taiwan, was this Intel Capital Ultrabook Fund. Now this fund is $300 million that's going to be spent over the next 3 to 4 years. And what we're trying to do with this fund is we're trying to invest in companies or help companies along who are enabling technologies that will help Ultrabooks. So think about things like batteries. In order to get to all-day battery life, yeah, we're going to do stuff on silicon side, but we still need to advance battery technology. We'll look at new battery chemistries or making standard cell sizes for lithium polymers so that the cost can come down there. We'll do work with storage because SSDs are small and these systems are great. The SSD versions of these systems are really great, but you don't have quite the density you do on a hard drive. What can we do to bridge that gap? What can we do in the area of materials or chassis? If you think about it, there's some systems that are using pressed aluminum today that's shaped, but it's done one by one. You can't do volume manufacturing that way, and so it tends to be expensive. So this fund is going to do equity investments and other types of investments in companies that are helping develop an ecosystem that will support Ultrabooks at mainstream price points. And of course, Intel has a whole roadmap of products. I just wanted to explain to you on this second to last slide that we are going to be moving our silicon forward. The first Ultrabooks you're going to see in market will be based on the second generation Intel Core processor family. And then next year when we launch Ivy Bridge, which is going to be the third generation Intel Core processor family, you'll see the systems really hit into the mainstream. So we're starting the category now, and then we take it to the mainstream on Ivy Bridge. And then in 2013, where I showed that new design point, that's where that happens. So a lot of innovation and momentum going forward over the horizon. This is something that Intel is very committed to. So in summary, I talked about how there's tremendous growth potential ahead. And we really do believe that the Ultrabook is going to transform the PC. And we're investing heavily to make sure that it does so. So the last quote I'm going to leave you with is by Alan Kay. And I think it's a great lead-in to the speaker who's following me. It says, the best way to predict the future is to invent it. So with that, I'm going to go ahead and hand off to